We have a lot of data. We do a lot of data as scientists and engineers, but most of our data is actually structured data. So structured data means it is either continuous data, it's numbers, it's ordinal data, we have number levels, or it's categorical data, and we have levels, or it's pass-fail data, or maybe it's a survey data with Likert scale, something like that. But there is a structure to it. We also do have a lot of unstructured text typically, but in my case, for a long time, it was just sitting somewhere. Data like product reviews or customer surveys, service call records, or product incident reports was one that a customer mentioned, or a narrative clause, maybe someone who was very diligent and commenting on DOE runs or on manufacturing runs or something like that. So the data is sitting somewhere. We might take a look at it, but we are not doing something systematic with it because it's not in a format that we typically work with. There's actually a lot we can do with this data. So today we're going to talk about this unstructured text analysis. Some of the questions you may have when you take a look at this data are questions like, okay, which words are most commonly used? Are there words that appear together? What is the context for some of these keywords? Are there recurring themes in this text? Is there a sentiment that is conveyed? And of course, the Holy Grail, can I use this information in a predictive model? That would be fantastic, right? If we could do that. So for today, we're going to take a deeper dive into text analysis. First, I want to give an overview of how text analysis is different from the usual the usual data that we work with, just to set you up so you know how the process will look like. We're going to do a really quick 101 text analysis, some vocabulary and process steps overview. And then we're going to see different examples of how that text analysis could look like. Going to see how we're going to go from some random text comments here at the top to a meaningful word cloud to maybe a latent topics analysis where we're really getting some granularity on what are the topics that are mentioned in all these comments. The data set we're going to work with is a data set from health inspectors visiting restaurants. And so state local authorities have to inspect food establishments against violations against the food code, and they have to log this data, and this data has to be publicly accessible. That means for some cities, you can request this data. For some cities, you can look up this data per establishment. Minneapolis, which is close to where I live, has all of this data in a database, and it's publicly accessible. There's a link down there, open data, minneapolismn.gov. They have other interesting data sets as well if you're from this area, so you can take a peek. I pulled this data last year, and I pulled it for about 2.5 years. So all the data for all the food establishments in Minneapolis, Minnesota. So what are some of the questions you might have when you pull this data? Well, of course, the first question is, okay, I was going to go out for dinner tonight. Should I go to this restaurant, or do they have issues that make me want to pick a different restaurant? That could be one. But generally, questions that we have are, okay, what are the common issues, right? If I am a restaurant owner, that is helpful because I can focus on where I need to train my staff, may do a better job in training my staff in. If I work for a cleaning product company in R&D, I might find this data helpful because it can inform where my product innovation can focus on. So we're going to take a deep dive into this topic. Just a little side trip here. Let's look at a vocabulary that is used in text analysis. On the left, you see a data table here. It's a sample data set from the JMP library, and it's showing survey data. And when we start text analysis in JMP with the Text Explorer, we get an overview, a summary. And there's some words in here that I just think might be helpful to know up front. We see words like tokens and case. So what are these things? Well, in text analysis, each row or each response in each cell is called a document or a case. The collection of all of these together are called the corpus. So basically my row or my cell is a document and the data table is the corpus. I have words that are terms. These are the words that have a meaning in the context that I'm looking for. And I have words that are not meaningful in the context of what I'm trying to figure out. So those are called stop words. And all of these terms and stop words together are called tokens. So when I start Text Explorer, I get a term list to start with. I get a number of unique terms. I get a number of cases, and that should match up with my number of rows in the data table. I get the number of non-empty cases, so it lets me see that, yes, there were some empty rows here. And then I get a total number of tokens. So if I take all of these responses and put it in Word and do the word count, I get 1,921 words. That's the number of tokens. The process for text exploration kind of as follows. First, we just set it up. The only thing we have to decide up front is maybe if we want to use whole words or word stems. For example, I can use the words jump, jumping, and jumped individually, or I can chop off the ending and just use jump with a dot here, which then encompasses all of these 3 words here. This is also something I can decide on later to apply at a later stage, so I don't have to do it. Next, we have to curate that term list that comes up. And this is a really important step. And it is so important that we're going to have to come back to it. So we're going to do step 2. We're going to do a first iteration at curating this term list. Then we're going to assess how well we did, looking at the word cloud, looking at some analysis. And then we're most likely are going to come back to doing some more curation. And so this is the big difference when we do unstructured analysis versus structured data analysis. When we have our regular data, we do all our data cleanup up front. And usually after we're done with that, our data set is ready for analysis and we don't have to come back. Maybe here and there, tweak an outlier or something, but 95% of the work is done up front, and then we're ready and set to go for any of the analysis we want to do. In text exploration, this is absolutely an iterative process, and I think it's helpful to know that up front so you don't get discouraged after the first round and think, why doesn't this make sense? Well, it just has to go through a couple of rounds. Just for fun, since we're talking about stop words, these are some stop words to give you an idea of what those could be. Of stop words I pulled out for that health inspection data set. So numbers or parts of a URL, words that are not really meaningful. What are the types of results we can get from this? I put the questions back here that I had on an earlier slide. What are the most common issues? How would we answer this? We could answer that by just kind of looking at how each of these documents scores against certain keywords. So here are some keywords that came up: ANSYS, containers, temperature, and a percentage of those 22,000 documents that contain some of these keywords. So that can be insightful. And that is something we can do in standard JMP. It is lacking a certain granularity. For example, temperature doesn't tell us necessarily what is the issue with temperature. So there are other things we can do. We can look at combination of keywords, for example. We can also dig in more and use other tools. And some of those tools are in JMP Pro specifically to find out maybe what clusters occur with these keywords or what latent themes are there. And here we see a pie chart with some of these clusters that I found doing this analysis. And for example, we can see a bucket for, I shouldn't click here, a bucket for heat sanitization. So temperature might occur here, but also cold storage is a category of violations where temperature may occur. So we definitely get more granularity when we use some of these other tools.